Hi guys, in this video we shall learn about potentiometer and its working. Let us first see what a potentiometer is. It is a 3-terminal resistor with a sliding contact that acts as an adjustable voltage divider. It is essentially an instrument used to measure the electric potential. As you can see, the 3 terminals are VCC, signal and ground. To the signal terminal, a green strip is attached. This is called the wiper. It moves across the outer dark circle, which is the sliding contact. Initially, when the wiper is nearer to VCC, the area between wiper and the sliding contact is minimum. So resistance across potential and the voltage drop across it is also minimum. We can change the position of the wiper by turning the knob of the potentiometer. As I rotate the knob in the clockwise direction, it keeps on moving towards the ground terminal, and the area between the wiper and the sliding contact increases, thereby increasing the resistance and the voltage drop across the potentiometer. In this way, the potentiometer has many applications. It can be used as a variable resistance or as a voltage divider circuit. Let us see how the potentiometer is used as a variable resistance. In this circuit, we have connected a 10 kilo ohm potentiometer to a digital multimeter and set the mode of the multimeter to resistance mode so that it will display the resistance across the potentiometer. We have connected the middle terminal and the end terminal. So when the knob is nearer to terminal 2, the potentiometer will have minimum resistance, that is 0 ohm. As we slowly rotate the knob in the anti-clockwise direction towards terminal 1, the resistance across the potentiometer will keep on increasing and reach the maximum value. As you can see, now we are rotating the knob. When I bring it to the middle position, I will have exactly half the value of the total resistance, that is 5 kilo ohm. Now I further turn the knob and the resistance keeps on increasing, and as the knob reaches the end, we will get the maximum resistance. This is how the potentiometer acts as a variable resistance or a rheostat. There is another application for this among the many applications, which is using it as a voltage divider. Let us see how that is done. In the given circuit, there are two resistances R1 and R2 connected in series. I want the voltage across R2. This can be obtained by using the voltage division rule, which states that voltage across R2 is equal to total voltage, that is supply voltage, into the resistance across which we need to measure the voltage, R2, divided by sum of the total resistances, that is R1 plus R2. So VR2 is equal to V total into R2 by R1 plus R2. Now let us see how to practically realize this circuit using a small simulation. As you can see, I have connected two resistances R1 and R2 in series with a 9-volt battery in the circuit. Now I have taken the value of R2 to be a constant, that is 5 kilo ohm. The aim of this is I want the resistance across R2 to be 3 volt. So I should change the value of R1 for that. I should basically increase R1 so that the voltage drop across R1 increases and across R2 decreases, and I get 3 volt across R2. But I need to know how much I should change R1. To find the value of R1, we can use the voltage division rule. In that, we set VR2 as 3 volt, and then using the formula, we can find out R1. We are getting R1 as 10 kilo ohm. Now, in the circuit, let us set the value of R1 as 10 kilo ohm. As you can see, the voltage drop across R2, VR2 is 3 volt as displayed in the multimeter. Say I want to increase this voltage. Now I want to double it. I want VR2 to be 6 volts. What should I do? I should decrease R1. So that voltage drop across R1 decreases and R2 increases. By how much should I decrease it? To find the value of R1, again we have to use the voltage division rule. By setting their voltage across R2, VR2 as 6 volts now, we are finding the value of R1 using the formula to be 2.5 kilo ohm. Now let us again change this in the circuit and see. Now I am changing the value of R1 as 2.5 and I am getting the desired voltage, that is VR2 as 6 volts. But this method is kind of long and time consuming and tedious. Every time I have to use voltage division rule to find the value of R1 and manually replace R1 to get the desired VR2. Instead of that, let us see a simpler method. Here now what we have done, I have replaced R1 with a potentiometer having 10 kilo ohm resistance. Now if I want 3 volt across my resistance R2, I simply have to turn the knob of the potentiometer and keep on increasing the resistance so that voltage drop across potentiometer increases and across R2 decreases. As you see, when I have set it at 10 kilo ohm, I am getting 3 volt. Now if I want to decrease the potentiometer's resistance, I just have to turn the knob, and that way the voltage across R2 will increase. This method is faster and it is also more accurate and easier to do. Of the potentiometer more clearly, let us see a small setup in which the potentiometer is used to control the intensity of the LED. For this we need jumper wires, one LED and potentiometer. This is the potentiometer. Here, as you can see, when I turn the knob, I can turn this knob, the position of the wiper will change, and so the resistance will also vary. I have connected only two terminals, end terminal and the middle terminal. So the potentiometer acts as a variable resistor or a rheostat. Then we need the breadboard and a 9 volt battery. This is the hardware setup. In this you can see that the potentiometer is connected in series with the LED as well as the power supply, and also we have grounded all the three together with a common ground. You can clearly see that even though the power supply is connected, the LED is still turned off. This is because the potentiometer is in maximum resistance position and most of the voltage is dropped across the potentiometer itself, and the LED does not receive sufficient voltage to turn on. If you want to turn on the LED, we have to decrease the resistance across the potentiometer. This can be done by turning the knob of the potentiometer. Now, let us slowly decrease the resistance by turning the knob, and you can see the LED immediately starts glowing. Now, let us further decrease the resistance. The intensity keeps on increasing. Now, I have turned it to the minimum position. So the resistance across the potentiometer is now minimum and the LED's intensity is maximum. Now, if we want to reduce the intensity, again we have to increase the resistance. So rotate the knob in the opposite direction. You can see the intensity is slowly reducing, and now it gets turned off. So this is how we control the intensity of the LED using the potentiometer. Hope you understood the working of the potentiometer. If you like this video, then subscribe to our channel for more such videos.